Hello, and welcome to the monograph titled 2020 Dreams Toward a New Understanding of the Dreaming-Waking Continuum. The following video presentation was designed to guide you through the project's research objectives, architecture, methodology, philosophical reflections, and empirical findings. The project you're about to explore is a digital scholarly monograph created from 2020 to 2023 and released in November 2023 as part of the digital publishing initiative of Stanford University Press. The project examines 2020, a year filled with historic global events, including pandemics, social alienation, media anxiety, and environmental crises. The primary aim was to investigate how and to what extent our dreams responded to the new reality. Co-authored and collaboratively produced, it represents a unique scholarly attempt to understand communities as seen through the prism of dream reports and trusted source of news articles. The monograph employs natural language processing tools and close human reading analysis to compare thousands of dream reports and news articles, drawing from linguistic, philosophical, cultural, semiotic, anthropological, and statistical frameworks. By visiting the project's website, 2020dreams.org, you will find 7 main sections. Each section is color-coded for clarity and features an opening image. As the reader progresses through sections, the images are replaced with their respective colors to indicate the reader's present position. Let's begin with the introduction. The research tests 2 main hypotheses. First, dreams offer meaningful reflections of both personal concerns and broader collective realities and have meaningful psychological structures. And second, dreams actively respond to collective concerns and create adaptive ways, particularly in times of widespread crisis and mass trauma. In addition to the central theme, 2020 Dreams intertwines computational intelligence with philosophical reflections on contemporary issues like mass digitization, artificial intelligence, and human-machine interaction. The project seeks to establish a transdisciplinary framework for future dream studies, leveraging both human and machine intelligence to explore the multimodal nature of dreams. Let us begin by describing the project's architecture and navigation. The 2020 Dreams offers 2 navigation approaches. The primary method, akin to traditional book navigation, follows a linear path. The reader can also follow the main sections clockwise, as seen in the example on the left. It represents a suggested, unidirectional reading, designed to lead the readers and visitors according to the author's proposed thread. The table of contents also demonstrates this method of reading. The second method, multidirectional, allows for modular exploration, enabling visitors to visually investigate the dense network of relationships, visualizations, empirical results, and tagging systems. For example, the visitors can explore the structure of the monograph using radial visualization by clicking on the compass icon in the upper left and selecting options from the visualizations menu. The visitor will soon notice that the deeper exploration of themes, particularly data visualization, requires more accurate spatial orientation. To address the navigation complexity with optimal efficiency, we have developed a map that illustrates the project's primary sections along with their respective chapters or pages. Moving on to the content, the project examines the events of 2020 through thousands of dreams and news reports. It analyzes semantic similarities by evaluating over 25 million comparisons between dream and news texts. There are several approaches to examining these connections. We define them as coniunities, as they represent the backbone of the project's empirical component. The best way to explore the results is by using multilinear navigational paths and interactive data visualizations. For example, the visitors might want to start with the introduction of the results section, where they can explore a top-down view of semantic similarities simply by clicking on any color-coded bubble that represents the dreamer. The visitors can also explore these semantic correlations on a group or individual level, as demonstrated here. In addition, the chart allows them to explore and compare how the time difference between the occurred dream and the published news affected the semantic similarity. Let's say we're interested in Bob, whose dreams show a high correlation with news. Look closely at the following outlier. This dream news pair indicates that Bob had pandemic-related dreams 51 days before the news article addressed the same topic. We can closely examine the dream content on the left side and compare it to the news on the right by clicking on any bubble in the chart. Dreamer word search findings provides another way to explore the dream content of individual dreamers. In the radar charts, the visitors can explore to what degree the individual dreams differ from the statistical baselines. The baselines are pre-calculated statistical values based on Bulkley's pioneering research on the sleep and dream database. The radar charts were developed for 8 categories commonly appearing in dreams, such as perception, emotion, characters, movement, cognition, and so on. The visitor can compare female and male baselines to any of the 10 dreamers by navigating through radar charts. The reader can also learn about the author's analysis, which utilized a close reading technique. The findings are discussed in the Dreamer correlations chapters. The authors studied a representative samples of individual dreams using a close reading or human reading method. Their perspectives have been influenced by their backgrounds in theoretical psychoanalysis, anthropology, psychology of religion, cultural studies, sociology, and media studies. Let us walk you through the study's most significant findings using the explicit semantic analysis method. The first chart represents the monthly and weekly distribution of dream news pairs according to semantic similarity. One of the most intriguing observations can be seen in the October Dreams versus April news bubble, which shows a relatively high degree of similarity, irrespective of the fact that the dreams and the news were 6 months apart. The weekly distribution of dream news reveals a moderate and steady increase of semantic similarity over time. By clicking on each column, the visitor can examine selected samples of high, indicative, low, and indiscernible semantic similarities between dreams and news. The third chart represents the monthly distribution of 4 semantic similarity categories. The highest average similarity scores can be observed in March, April, and May, the most significant months that mark the beginning of the pandemic breakout in the United States. Here's the last chart, also called master visualization, which represents a macro view of dreams and news report similarities for each day of the year. The daily number of dream news comparisons is utilized for calculating the average daily similarity values. Here's the principal finding of the study. Based on the available data, the modest but constant growth of the curve may imply that the semantic similarity between dream reports and news becomes more pronounced over time. In the last few minutes of this presentation, we will briefly describe the remaining 3 sections of the project. Reflections. This section offers theoretical and philosophical frameworks on dreaming and waking reality, along with critical approaches to mediated and digital reality. The second part is dedicated to human machine anthropology and the rise of digital technology while exploring the inseparable aspects of the human and machine. The section also reflects on cognitive technologies and how they have dramatically extended and externalized human consciousness. Methodology. 2020 Dreams is built on 2 methodological approaches: Dreamer Word Search, derived from Sleep and Dream Database, which allows users to choose among 40 categories of words organized into 8 classes of dream content, as demonstrated earlier in radar charts. The second part of the methodology is based on explicit semantic analysis, originally developed by Gabrilovic and Markovic. For our study, their method was further adapted and developed. Explicit semantic analysis is a method of representing texts using a system of vectors and document corpus used as an explicit source of real-world knowledge. The document corpus standardly used in this method is Wikipedia, which is a comprehensive and open source repository of categorized world knowledge. The method of analyzing textual similarity using explicit cyclopedic information has been shown to have higher accuracy than other NLP tools and was thus used to compare news articles and dream reports in our study. Let us now walk you through conclusions. This final section consists of a general overview of results. It also analyzes the rapid expansion of psychological digital repositories, which inevitably leads to data ownership and data management concerns. The final chapter of this section offers some insights into the future of dream research and science. The last two sections are works cited and appendices and repositories with all available codes. Thank you for watching.